All right, so this is where we stopped on Friday. We made the table, right? So the background on this question was it's a daily lottery question. Daily lottery, you pay $1 to play. So $1 you get to play. If you pick you pick a 3-digit number, whatever 3-digit number you want. Remember we said from 000 to 999. Pick any number you want. If your number comes up, you win $100 or $500. You win $500. If you lose or if your number doesn't come up, you just lose the dollar. Okay. So if I played once, right, you could play more than once. You had $5. You could pick 5 different numbers, but this is based on once. Okay. So if you picked or if you played once, there are two things that could happen. You could win $0, right? That's a loss. Or you could win $500. That's a win, right? There's nothing else that could happen when you play this game. Okay. So the chances of winning $0, so not winning, are 999 out of 1,000 because there are 1,000 different 3-digit numbers, right? From 000 to 999. And um, and you only play once, so you pick one number, right? So you win $500 if you pick the right number. That's 1 out of 1,000, right? So we stopped there. We made the table. Okay, so now there's two questions. What is the mean? In other words, what would I expect to win if I played this game? Now, just kind of without doing any math, what do you think? What should I expect to win? Pretty close to nothing, right? Pretty close to nothing. If you do win, it's really chance, right? It's really chance. Okay? So let's verify that with the mean. So let's use the mean. So we're going to find the mean, and then we're going to find the standard deviation of this game. Okay. So mean is the same thing as expected value. What would I expect to do? What would I expect to happen if I played this game? Well, the first thing that could happen is you could win $0, right? So $0, and there's a pretty good chance that that's going to happen, right? And $500, right? Could win $500, but there's a pretty good chance that you're not going to win $500. Okay, that's the only two things. So I don't even think we need L2 and L1 and L2. If you want to do it, you can, but if you don't, you just multiply. The first one's going to be 0, since 0 times anything is 0. The next one is 5 times 0.001, and you get 0.005. Is that right? Did I do something wrong? 500. Sorry. Oh, sorry. It's 500. Sorry. 0.5. 0.5. Okay. That's the expected value. So if I were to play this game, this is in the long run. This is not once, right? Because could I win 50 cents in this game? No, I couldn't win 50 cents in this game, right? But in the long run, if I were to play this game 1,000, 10,000, 5,000, a million times, I would expect to win on average about 50 cents every time. Okay. Well, hey, I'm winning money. Should I play this game then? I'm making money, right? If think about it. If I play a million times 0.5 is $500,000 I could win. But say it louder, Kaylee. What's the problem with my logic? So I'm having to pay $1 to play, right? So if I play it a million times, if I play this game a million times, I win $500,000. But how much did I spend? $1,000,000, right? I pay $1,000,000. It's not really hard math. It's $1 times a million, $1,000,000. Yeah, yeah. This is not too bad math. Okay, So $1 million I would have to pay to win $500,000. What's another way of saying that? There you go. I'm out $500,000.
That's like half the glass empty, basically. You have to have a positive.
I don't know if there's anything positive about losing $500,000.
It's only negative if you look at it.
Okay.
If you only look at how much you win.
So this is how I would say it. This is how I would say it for this game. For every game played, or not for every game played, for every dollar wagered, I should say, for every dollar wagered, I would expect to win 50 cents. So for every dollar, so in other words, you give someone $1, they give you 50 cents back. Keep doing that a million times. Exactly. Exactly. Okay, so it's not such a good idea to play this game. Right? So here's another question. Before I do the standard deviation, could I have done this table this way? Because some people will do it this way and want to see if it makes sense. Could you have done it this way? So negative $1 and $499. So think about where in the world do the negative $1 and $499 come from?
Well, you're spending $1 to win, right? You
spend $1, you gain 500, which is the only two.
So yeah, so you're thinking about, so the way this works is it's the same as this, right? This is purely win. This is kind of like what happens, right? If I lose, don't I lose $1? And if I win, I don't win $500. I win $499 because I just get my dollar back, right? So if I do it this way, it would still be the same probabilities, right?
Maybe the mean is different.
The mean would be different. Do that quick mean real quick. Do the calculator. Do the mean for this one here. Tell me what you get. It is different. And I want to explain why. So what is the mean here? Tell me real quick when you guys do that.
Negative 0.5. It's the x with a dash on top, right? Yeah, x more. Negative 0.5.
So negative 0.5? That's very close, right? So what's the difference between this table and this table? How do I interpret it differently? Because this one is fine, right? We could have done it this way, right? That would have worked. And I would have gotten negative 0.5. How would I interpret that differently than the one I got here, which is positive 0.5? Yeah, that's what it would. You would say lose as opposed to win. Same thing, right? It's the same idea, right? Your interpretation would be for every game played, I would expect to lose, or for every dollar wagered, I would expect to lose 50 cents. It's the same thing as saying you would win 50 cents, right? So a lot of people see it this way, and we're going to do the next problem. This might be an issue too. Some people see it this way, where, okay, there's two things that can happen. I can lose $1 or I can win $499. Some people see it this way. I could win nothing or win $500. It's the same thing, right? You get different numbers for expected value, but they mean the same thing, right? Okay, standard deviation real quick. Let's do standard deviation. So standard deviation, you guys already have the number if you guys already put it into the calculator, but where does the number come from? So the first one is 0 minus 0.5 squared times 0.999 plus 500 minus 0.5 times 0.001 squared. And then we want to find the square root of that. So when you do that, what do you get? Those of you that put it in L1 and L2? 15.803. Okay. So on average, for every dollar wager, I would expect to win 50 cents in the long run. That number will vary by about $15.80. Yeah. It's not going to go lower than 15. It would be negative, right? So, yeah. And then if it goes up by 15, that's $15, $16, right? I can't win $16. So it's a lot more likely that you're going to lose. It's a lot closer to zero, right? If I take this number here and I add this, that's 16, about $16, a little over $16. Well, I can't win $16. I can only win 500. That's pretty far away from 500. But if I lose, I subtract this, right? It gives me negative $15 and change. That's a lot closer to zero because the chances you losing are a lot higher. Okay. So, should you play?
Yes.
If you like money, if money is important to you, should you play?
Yes.
Absolutely not. Absolutely not. Because just like we said, you're literally giving someone $1 for them to give you 50 cents back every time you play. That's okay. Okay, so the next one. The next one has nothing to do with gambling, but it is something that you see a lot of. Insurance companies. So insurance companies. So for those of you that don't know, someone explain to me how insurance works. Insurance on anything: cars, house, life insurance, health insurance. How does that work?
You pay for something, or you pay for the insurance, and the insurance usually covers a portion of something damage.
Something happens, right? So it's like a safety net, right? You have health insurance because if I have to go to the doctor charges $100, $200 per visit. It's a lot of money. It's a lot of money just to go to the doctor, just to go to your regular doctor, who, just general practice doctor. It's 100 to 100, $200 a visit, right? That's expensive. So you buy insurance. The insurance covers the cost. They charge, you pay like $20, $25 if that, and they pay the rest, right? Why do they do that? Because you give them money every month. You give them money every month, hundreds of dollars every month. And if you're the kind of person who doesn't go to the doctor often, your insurance is low. But if you're the kind of person who needs to go to the doctor quite a bit, your insurance goes up, right? The older you get, your insurance goes up, right? You guys are, as long as you guys are 18 or younger and in school, state of California covers you. State of California covers. Now you might be a part of your parents' insurance too, but even if that wasn't the case, the state of California covers you guys. Okay, it's called Medicare, something like that. Not Medicare, Medi-Cal or Medicaid. Okay, so that's California. That's California. Other states are different. Okay, but once you turn 18 and graduate from high school, then you're on your own. Okay, so like I said, if you're still on your parents' health insurance, they'll still carry you, but if you don't, then you have to have insurance on your own. Okay. Car insurance, same reason, right? When you drive a car, anyone who drives a car has to have car insurance. It's required by law. You have to have car insurance just in case you get in an accident, something happens. Even if it's not your fault, you still have to have car insurance. Because just in case, right? Just in case something happens, right? I give the insurance company $50 to $100, whatever it is a month. If something happens, right? Insurance says, okay, we'll cover it. Okay, we'll cover thousands of dollars, whatever it is, right? Health insurance, death and disability. So this one is death and disability. An insurance company offers a death and disability policy that pays $10,000 when the policyholder dies. Okay, so that's the death part. Which the company estimates to occur 1 out of every 1,000 people. Okay. Or they'll pay you $5,000 when the policyholder is permanently disabled, means they can't work. Okay.
$10,000 really.
What's that?
Well, like if family.
If they die, family members, yeah. No, yeah. If you have life insurance, yeah, So the money goes to you. When you sign up for the policy, you got to put people down who you want to give the money in case you die out. Yeah, they get it, right? Yes, yes. For death for life insurance, like life insurances are usually in the 100,000s, if not millions. Okay, but yes, this is pretty low. So $5,000 if you're permanently disabled, so you can't work. Okay, estimated to occur 2 out of every 1,000 people. Based on actuarial information, the company has calculated the probability shown in the table below. There's no table because we got to create it. Okay, the company plans to charge $50 per policy. So to get one of these policies, they charge you $50. Just one time, I think. Yeah, one-time policy of $50. So the random variables are going to be the profit. Okay, that's going to go in the left column. The random variables go in the left column. So let's make a table. And probabilities go across from it. Okay. So profit. So this is profits, and we're going to say in money, and the probability of that money is going to go right next to it. So what are profits?
Money that you get.
How much you make after
the cost.
Yeah, after the cost, right? So if I sell pencils, and it costs me a dime to make this pencil, right? And I charge $1 for this pencil. $1 is not my profits, right? 90 cents is my profit, right? That's the money that goes in my pocket, right? 10 cents I have to go back to the cost to make them. Okay, so profits. So what are the things that can happen if I have this policy? Don't worry about numbers right now. What are the things that could happen? I could die. You can die, right? What are the other things?
You can get disabled.
I can get the disability, permanent disability.
Or you get disabled and die.
I don't think that can happen.
Like you get disabled and then like 10 years later you like fall.
If you get the 5,000, I think that's the policy's over.
Oh, it's an or. No, it's an or.
Yeah, it's
It's terrible.
So
$10,000 and they die though?
yes.
So then why does it say 1 out of every 1,000 people?
Oh, that's the probability that happens. It happens. So if you die and you have this policy, they'll give you $1,000. No, $10,000. But that's the probability that goes with it. What are the chances that someone's going to die? 1 out of 1,000. Okay. So I could die. I could get disabled, or
you get disabled and you die, or you don't die, or neither.
Neither. You live, right? That's the chances because what's the chances that I die? 1 out of 1,000, right?
Yeah.
So 1 out of 1,000. So let's write the probabilities. 1 out of 1,000. 2 out of 1,000 are for disability. So the leftover is what? 997. So we know the probabilities each of those things is going to happen, right? But what are the profits from? See, this is where it doesn't say. Oh, made by the company. Sorry. So the company. What are the profits? So in the chance of 1 out of 1,000, how much money is the company going to make? It's going to lose how much? Not 10,000. You're close. There you go. 9,950. Good. Yeah. Kuldeep, how'd you get that number? How'd you get 9,950 profit?
Yes. Wait, is it 1 out of every 1,000 people that get the policy?
Yes.
So what do you do? Like 50 times 1,000 first, and then
50.
you minus it by the one person that died.
What are you talking about?
Well, okay, so it's 1 out of 1,000 people that get the policy, right?
In the long run, they found that 1 out of 1,000 people who get this policy will die.
So if they sold the policy to 1,000 people, isn't it 50 per policy? So 50 times 1,000, because 1,000 people got the policy.
Or are you saying 10,000? No. It's just saying in the long run. They've sold this policy to millions of people. Right. They're just saying, based on their actuarial information, Actuarial. Well, what word does actuarial look like?
Actual.
Actual information. Based on the actual information that's happened, about 1,000 people, 1 out of every 1,000 people have died.
So you wouldn't count.
This is just for one person. We're just trying to figure it out for one person.
You wouldn't count the profit you've already, or the money you made off of the other thousand, the other 999 people that bought the policy that didn't die.
No, there's more than that have made it. You know what I mean?
Okay.
They've had millions. They've sold this policy million.
Understand what I'm saying?
They've sold this policy to millions and millions and millions of people. How do you know? Well, my question is, how do you know how many people they've sold it to?
Well, because he just told me that 1,000 people at least bought. Out of 1,000 people that bought the policy, one of them is gonna die.
Yeah, so 1 out of 1,000, right? So that's what?
Everyone's going in circles, man.
It's been sold to more than 1,000 people, right? But we're using
Right.
one.
Okay.
Right?
So
So
it's just-
one person buys it.
Yeah.
Oh, okay. All right. Oh, thanks. All right. Well,
It's literally what I said about 3 times.
Can you explain where you got that negative 9,000?
Yes. Kuldeep, can you explain one more time where you got that?
my bad, Kobe.
Because the company has to pay out.
So this is the company's profits. This is not your profits. My profits, that's positive,
That's
right?
bad.
Yeah, exactly. My profits, that's positive. The company's profits, because that's what it says in the question, right? The company's profits per person, theirs is they lose money. They lose money if someone dies because the person only gave me $50, but I gave them $10,000 back. So I'm out $995 or 9950. Okay. Okay. So what are the so 2 out of 1,000? 2 out of 1,000 is if they're permanently disabled. So how much does the company gain or lose based off that? There you go. Negative 4950. 4,950. Because they gave you, the person gave the company $50.
Right.
Then it turned out they were permanently disabled later in an accident or something. So they had to pay back $5,000. So the people that got the money made 4,950.
Wait, we're not giving it out twice.
We are, but it's for the individual.
Oh, okay.
Okay. This is every individual. This is not, yeah. Okay. Because, and I'll tell you why. We can figure it out later. Okay, so 997. How much profit?
$50.
They're gonna make $50 off of. See, so that's why I don't really like fractions here, because it makes you think that there's 1,000 people. It's not. There's not 1,000 people.
That's not like.
That's why I keep it like that.
1,000 people, one of them died. 50 times 1,000 minus 50.
Yep. I like percentages or decimals instead because that gives you a clearer picture. You can change that to a percent. You can, that kind of thing. Okay.
If with their profits, it shows that like they're losing $100 instead of 50. If it's per single individual, so shouldn't.
Yeah, this is all based on a single individual. Yeah.
But so if they're already losing 50
For this one and this one.
yeah, shouldn't it, one of them be negative 5,000, negative 10,000 since it's one individual? Like,
No, so to get this number here, I paid the company $50.
yeah,
So the company makes $50.
yes,
And then they turn around and give me $10,000.
yeah.
So I'm out that $50.
I know, but if they're all for the same individual,
Like they have both plans.
whatever it is, like the company, it's showing like it's the 50's been subtracted twice,
50's been subtracted
like
twice.
from the 10,000.
So subtracted just once?
Yeah, but if it's for one individual, why is it subtracted from the 10,000 and the 5,000?
Oh, I see what you're saying. 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 Oh, okay. So
Each
so
person
think of
gets
these
a-
as different events. So they're different events. It's not the same person like going down the list. It's different events. Yeah, I see what you're saying. So like, yeah, I'm one person. What are the things that could happen to me? This one here, this one here, this one here. I see what you're saying. Yeah. Okay. Yeah. Yeah. I'm not saying everything's going to happen. I'm just saying this is like the menu of things that could happen.
So there's like, we're not going for an and statement
No.
here.
Okay. All right. So now what I got to do is I have to use these probabilities to figure out what would the company expect to come profit in the long run if there were millions of me, thousands of me, right? So we're going to use expected. You're going to use your calculator if you want. Expected value. Okay, let me know what you get.
30.
$30.
30.
Anyone else get that number? Usually if two people get the same number, it's usually the right number. The chances of two people doing it the wrong way exactly the same is not very high.
Yeah, 30.
Okay, that works. We don't need standard deviation for this one. Unless they ask you specifically for standard deviation, you don't have to put standard deviation. You could, it doesn't hurt. It's the number's right there in front of you. But this one we don't. Okay, so $30.
So they make $30 off of
That's my next question. How do I interpret that $30?
for every plan sold, the company earns $30.
For every
Policy,
policy sold,
the company gets
the
earns.
company profits.
The company gets a $30 profit.
Yep. So a lot of people see these negative 9,950, negative 4,950. They're like, whoa, 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 how are these companies affording this? How can these companies afford to give all this money out? Well, that's what insurance companies do. They know that in the long run, most people, when I say most people, I mean almost everyone, is not going to die unexpectedly, knock on wood, or get permanently disabled, right? Now, they're not going to give these to someone who's 90 and in bad health. They're not going to give them to someone who's like an 80 or in bad health. They're not going to give them to someone who's like me in their 40s in bad health, right? They're going to give it to someone. That's why anytime you get health insurance, anytime you get any type of insurance, the first thing they do is go to the doctor. I want you to they look for a physical. And they want to see what health, not only what health, but what kind of health, what kind of health issues are in your family. Like you're like, I've never had that disease. Well, I don't care. Your grandma passed away from it. So it could come down to you, you know? So a lot of these companies will have you do that because they don't want to give health policies to people who are more than likely. They don't want these probabilities to go up because then guess what? This $30 goes down, right?
So for the death policy, right?
Yep.
When is it? So it isn't issued out for normal deaths, like natural deaths.
It's on the job deaths.
Might be on the job deaths. It might be.
If you die outside of the job.
Yeah, usually for like these low ones, like $10,000, it's the job. Like if you get a job, they'll have their own insurance on you.
Do you have life insurance?
Do I have? Yes.
You could die on the job here.
No, my life. I have two life insurances. I have one life insurance through my personal,
Right.
where if I die anyway,
Right.
my family gets money.
Okay.
And I have something like 10,000, 10, 20,000, something like that with Central Unified. Central Unified has policies like this on all their teachers. And if something happens to us, I don't even know necessarily it's on the job. Might not be on the then we get that money. Beneficiaries get that money. Yeah. Yeah. Because in California we have things called workers' comp, where if you get hurt on the job, you're covered. So yeah, so the insurance. Yeah, exactly. Exactly. Knock on wood, doesn't happen. But yes, that's how insurance companies make money. That's how insurance companies make money. They don't like to pay people out. They do not like to pay people out. For example, to get insurance for a house in Shaver, fire insurance for a house in Shaver, the prices for fire insurance for houses in Shaver has gone through the roof. People can't even afford it anymore, so they don't have it. So unfortunately, if a fire happens, they're not covered, you know? And why has the prices gone up? The fires, the amount of fires we've had in the last few years. The amount of fires. The amount of fires we've had in the last few years is just crazy. So yeah, things like that happen. Things like that happen when something, yeah. So that's why that's how insurance companies make money. If they weren't there, if they didn't do this, they wouldn't be able to give insurance to everyone. Okay, so yeah, so as much as they have to pay out, they take in a lot more money. Okay, they're called premiums. Whatever you pay, like this one's $50 to pay, right? It's called a premium, right? Why are teenagers have the highest car insurance of anyone drivers? Of any drivers, teenagers, it's the highest risk of something to happen, right? Ticket, accidents, anything like that, right? Because that's why it is, right? They have data to back that up. Once you turn about 25, the numbers go down. The numbers go down. And like when I had car insurance when I was a teenager, we had there was like you got discounts if you were a good student. Like if you could prove to them you had like a 3.0 or higher, it went down a little bit because that meant you were more responsible, right? So I don't know if they still do that. They probably do. But like I said, teenagers, especially males, teenager males are like the highest. It's crazy what the monthly premiums are. But um, as you get older, they go down. Unless you've had things like tickets or accidents or stuff like that, then they stay up. So that's why you want to make sure that you're a safe driver. Okay. Okay. We've done this is a lot of discrete. We've done a lot of discrete stuff. This is the only time we're really gonna cover continuous random variables. And the reason why is read the question. Read the question. So does this type of question sound familiar? It should. You guys did this back in chapter 2. That was a while ago, but still not that long ago. It was the types of questions that you had. Remember, you had to match the green, the little green cards with the percentages and stuff. That's this type of question, right? So you guys have been doing this for a while. We just haven't. We were just calling it normal distribution, right? And you see normal distribution there. So let's kind of go back into our. Okay, so we have a mean. Normal distribution, we have a mean of 64 inches and a standard deviation of 2.7 inches. What did we do after that? Okay, so what does that mean? There you go. We draw the curve, we draw, label, and sketch. First thing we do is we label the middle. That's the mean, which is 64, right? It's the same as the median because it's symmetrical. We don't have to do that right now. Let's just look at the question. Let's look at where they want us to find. Between 68 and 70, right? So we go label those, shade those. That's where we label and shade. So 68 and 70 are above the mean. Okay, then we shade that area there. So what the question is asking is find the percent or the decimal or whatever for that. That's what the question is asking. So how do we do that now? What else do we need besides we did the picture, we sketched it. What were the next step that we needed to do? There you go. Say it loud, cool, deep. Z-scores. Z-scores. We need Z-scores for 68 and 70. Z-scores. So remember, Z-scores are the number minus the mean divided by standard deviation. So for 68, it's 68 minus 64 over 2.7. And then for 70, it's 70 minus 64 over 2.7.
All right, for 4, it's 1.481.
481.
Yep, and then the second one, 2.222.
Okay.
And I have to get my fancy paper.
Okay, so we got z-scores. So let me go label these here. 1.48, 2.22. What's the z-score at 64? There you go. 0. There you go. Okay. So yeah, I got to go to my tables now. I go to my tables.
It was the thick one, right?
If you tell me, I can help you out. I have one here. So what are we looking for here?
Z-score of 1.48.
1.48. Z-score of 1.48.
0.9306.
0.9306. Okay, so let's go back over here. Where do I put 0.9306? There we go, right here. 9306? So this part over here in the left unshaded part is 9306 because that was from 148. That was from here back to here. So all of this right here is 9306. Not what we want, right? So what's the next one we're going to do? We're going to do this guy here. So now what we're going to find is from here to the beginning. So now we're going to find this. And if I subtract the two, it'll give me what I want. So let's see. What was it? 9868. That goes all the way to here.
Oh, because 0 is zeros first.
Okay, so all the way to 70 is 9868. All the way to 68 is 9306. So to get the middle, I subtract them. What'd you get? 0.0562. Okay.
So the probability of that is that.
Mm-hmm. So we would say the probability of a young woman between 68 inches and 70 inches is 0.0562. Probably should say young woman's height because it refers to their height. Between 68 and 70 inches. Yeah, being between 68 inches and 70 inches is 0.06562. Yes, very small chance.
It's already in freedom units.
Oh, I meant foot. 68
5'8", 5'8" to 5'10" of a young woman. Are you a young woman?
Yes.
But I'm 5'8".
He's an old woman.
Okay.
Not everything's about
Don't
you.
talk to me about you old.
I know, right? Yeah, no,
Start arthritis.
Okay.
look, buddy. I'd slap you when my hair hurts too much.
Exactly. That's what I'm about. What are we doing next?
All right, let's see. I really don't want to do these yet because it's going to take some time. Let's see if we can do another one. Okay, find some space. I'm going to give you. I'll give you another one like that because I don't want to go on to the next section because the next section is going to take longer than we got. So I don't want to give that to you yet, but I'll give you a practice problem.
No, it's just fine space. A new piece of paper. Is there space on the back? Oh, there is free space on the back. Never mind. There's a question.
I shall make.
Okay. Okay, so scores are normally distributed. Let's see, you got a mean of 29 and a standard deviation of 4. That's what the n is mean. The n in front says it's normally distributed. I'm telling you that right now. Find the probability that, probability x is greater than or equal to 35.
It was 1.25.
No, it's not. No, it's not. No, it's not. No, it's not. Sorry. Yes, 1.5.
Hey, okay, much better. All right. Woo, I was gonna say, oh my god, I can't even do this. All right.
Okay, so I know.
It should have been 1.25. All of you superiority people think you're better than me.
What? Let's see. 1.5. What was the percent left of 1.5?
0.932.
9332. And
0.0668.
thank you.
I was gonna say.
Come on, 80%.
0668.
Yeah.
All right. Talk to Mr. 88. What about 110 over here?
110 is just, I can't even see it anymore.
Too far off in the distance.
Okay, done. All right.
Where did you even get a 110? Did you do like an extra problem? You just wrote in her own problem.
It's like that one guy looking up at you on a mountain, right?